Can you hear me? Okay, so this is 11th lecture and probably the last lecture before the exam. And after in the next lecture, we are going to look at the review. Okay, a revision kind of thing, whatever the main concepts that we covered. So first of all, I think I saw that some of you are asking questions on WhatsApp that what is radius of convergence of a power series and so on and so forth, right? So I think I thought probably I should clear that because that's the important thing. Actually, you should know that. Okay, and then we'll go to the proof of the Taylor's series, especially in I'll show you that the Taylor polynomial is bounded by some fixed number, right? There are some conditions basically. So first of all, okay. So I start with the series. Summation n is equal to 0 to infinity an x raised to power n, or I call it x minus a raised to power n. Okay. Series is summation an x minus a whole raised to power n, because the Taylor series expansions are also like that, right? With an is that derivative divided by factorial n, something like that. So what is the radius of convergence and why it is called radius of convergence? That's something important to know. Now this series is an infinite series, right? So sometime we are able to find sometime we are not able to find it, right? So sometime it will converge, sometime it will diverge, right? Depending on what are the values of AIs and so on. Now, here, those values of X for which we are able to find the sum is known as, that series is convergent for those values of X, right? If you are able to find some, right? So normally, what happens, series is convergent if mod of X minus A is less than some fixed quantity. Okay. Now, mod of X minus A is less than what quantity that I will determine right now. Okay. And so basically that means, suppose that fixed quantity is capital R. So then that means minus R less than X minus A less than capital R, right? So X lies between these things, right? So actually X lies between an interval, right? So why we call it radius? Because in 2 dimensions. So for example, in if you look at, or even for the complex number. So suppose in that case the condition becomes mod of z minus a less than r, and then that represents a circular disk. Okay, so that's why the radius turns out to be this quantity. Okay, so the radius of convergence. Okay, so anyway, so that is the reason why it is there. So it will be more clear when we look at the complex things. Okay, anyway, I'll show you, but because in complex, mod of z minus a is equal to r gives you equation of a circle of radius r, if you can visualize it. Okay, so that is the reason it is called radius. But in 1 dimension here it is a interval. Okay, so value of x lies between, so minus r plus a and r plus a in between that. Okay, so that is the reasons. Okay, so now I have to find this radius of convergence, means those values of x for which the series is convergent. How do we do that? So I will apply ratio test. I compute limit n tends towards infinity, un divided by un plus 1 mod. Okay. What is un here? So this is nothing but limit n tends to infinity, mod of an x minus a whole raised to power n divided by an plus 1 x minus a whole raised to power n plus 1. Right? I have taken un to the whole thing, right? An times x minus a raised to power n is un. So ratio test was, you just compute this thing. Now this is nothing but limit n tends towards infinity, mod of an divided by limit n tends towards infinity, mod of an divided by an plus 1 times mod of x minus a. Do you agree? Limit n tends towards infinity, mod of n over n plus 1 times mod of x minus a, because here the power is more, so that term come here, right? Now I have to find we know that series is convergent if this whole thing is greater than 1, right? That condition that I told you, the ratio test. This will imply that I can take this mod of x minus a on the other side. Mod of x minus a will be less than limit n tends towards infinity, mod of an divided by an plus 1. Okay? So this quantity, we call it as capital R, and this is known as radius of convergence. So series is convergent if mod of x minus a is less than R. Okay? So from this expression, I am able to find what is the value of R. Right? Easy? Now I can give you one or two examples here to show that if I ask you to find a radius of convergence, how do we approach? Okay. So basically we have to just compute this value and then we know the value of R, right? So let us take the well-known example that you are familiar with. If I take the series as summation n is equal to 0 to infinity x raised to n divided by factorial n. So clearly in this case, an is what? 1 over factorial n and a is what? 0. Right? So that means R will be limit n tends to infinity mod of 1 over factorial n divided by 1 over factorial n plus 1, right? You simplify, this value will be, this goes towards infinity, right? Because as it will be n, right? So that means R is infinity. So that means what are the values of x for which it is convergent? So it should be mod of x less than infinity. This implies that minus infinity less than x is less than infinity. This implies that radius of convergence is actually infinity. It is showing it for all real values of x, the series is convergent, right? Which is clear. You know this fact, right? This series is convergent for all real values of x, right? It's easy to compute, right? Let me give you another example. So basically, essentially, it boils down to compute this limit to find the radius of convergence, okay? Take another example. Summation n is equal to 0 to infinity 3x raised to power n. Now, can you find and tell me what is the radius of convergence? So an is 3 raised to power n, a is 0 here, right? An is what? 3 raised to power n. So an divided by an plus 1 will be 3 raised to power n divided by 3 raised to power n plus 1. Take the absolute value and take the limit. So value will be 1 by 3, right? So R is nothing but 1 by 3. So series is convergent when from minus 1 by 3 to 1 by 3 plus 1 by 3. So x lies between minus 1 by 3 to plus 1 by 3. Any doubt? Yes.
If we take a ratio test, then there will be a case where it is equal to 1, where the series may.
There are a couple of other things, but here actually what I am saying that I am just finding a condition when it is convergent. So that I have found. Because if it is greater than 1, I am only worrying about when it is convergent. Okay, so so essentially what I am solving for x, right? Solving what values of x will give you convergent. So I put the condition of convergence only. I'm not worrying about whatever the other case, right? So, okay. So for this series, radius of convergence turns out to be 1 by 3. So when minus 1 by 3 less than x less than 1 by 3, series is convergent. Okay. Now, I have given one example. Anyway, you should have done it in T time problem, but anyway, I'll give you some idea. I gave you questions like this. X raised to the power factorial n. Now, what is the radius of convergence here? Any guess? Wild guess? ये थोड़ा सा tricky है. अभी क्या है कि सारी पावर्स n की नहीं आ रही है, राइट? ओनली सो देयर इज सम गैप. 1 आ रहा है, देन 2 नहीं 2 भी आ रहा है, राइट? 3 नहीं आ रहा है, देन व्हाट इज कमिंग? फैक्टोरियल 3 व्हिच इज 6. So there is a gap. So you can write down the series as this kind of series is known as gap series. All powers of n are not coming. Gap series, right? Then how do we find the radius of convergence? Any idea? Yes.
n और 1 को ले लेंगे तो n plus 1 हो जाए. n फैक्टोरियल को पहले तो सेपरेट कर ले. n फैक्टोरियल को सेपरेट कर लेंगे तो n और लास्ट वाला टर्म x.
Anyway, इसके लिए चाहिए cup of tea, right? To enjoy the beauty here. It's a very beautiful series actually. अच्छा, मैं उत्तर बता दूं तो भी सोच कर उत्तर बताने पे शायद तुम लोग अटेम्प्ट कर पाओ, राइट? ओके, उत्तर इज 1. रेडियस ऑफ कन्वर्जेंस इज 1 हियर. ओके, सो हाउ विल यू अराइव एट द आंसर? आंसर तो बता दिया, अब रास्ता ढूंढो, राइट? कर लोगे? एक्चुअली इट कैन बी, you know, if you just observe, it's very easy to observe actually why it is 1. Yes. Actually value आप डाल के देखो, that's a separate thing, but what I'm saying that how do you show it actually it is 1? पर an तो यहाँ पे कैसे लगाओ ना, वो तो सारे टर्म्स इसमें है नहीं ना, गैप सीरीज है. Actually an can be defined, there is one way of doing it. An could be defined that if n is equal to sort of factorial, so I can say that, so okay, call it, I'll call it am, right? Because factorial n is already there. So am is equal to either factorial n or 0. There are two cases. Other coefficients are 0 basically if you expand the whole series, right? So gap series is there, then so you know the value of am now, and then you can apply whatever you want to apply. Okay, got it? कुछ समझ में आ रहा है? क्यों भाई? बहुत हो तो ऊपर से चला गया होगा, right? You can redefine the coefficient, right? So what I'm saying that am could be, I'm calling it is am. An की जगह am कह रहा हूँ because यहाँ factorial n. So when m is equal to factorial n, that is one case, and when m is not equal to factorial n, the value is 0. That turns out to give you whole series, right? Now you have am, now you play with it. That's one way of handling it, right? ये observation आता है, beauty, you observe it, right? Okay? क्यों? क्या सोच रहे हो? Okay, let me write. I am saying that, अभी मैं इसको क्या कर रहा हूँ? Okay, I am saying that am here, अगर इसका कोफिशिएंट am है, इसको m is equal to 0 से infinity तक कर दें, right? और okay, इस और भी आसान है. n is equal to 0 will give you what? 1 plus next n is equal to 1 will give you x. Next what you will get? X square plus हाँ, तो x, अच्छा x ले लो, उसमें क्या फर्क पड़ता है? x then अरे यार जो करना है करो, आई डजंट मैटर एक्चुअली, ठीक है. then x is equal to 6. right? तो ये series ऐसी हो गई, right? So I am saying that if you look at the coefficient in values पे factorial वाली values पे 1 है, right? All other places it is 0. So coefficient की value पता लगे तुम्हें actually ना? If I determine in terms of m, right? If I write the coefficient of the series as am, ms coefficient, so I'm saying the ms coefficient is, can I say that this is, 1 if m is equal to factorial n, and 0 if m is not equal to factorial n. Can I say something like that? If the coefficient is am, right? So this is something like that. For all factorial values, the value is 1, coefficient otherwise it is 0, right? So this is one way of handling. There is another beautiful way. There you can compare with the x raised to n actually, and then you can determine. So there are different ways. So all this comes from observation, right? How do we compute the radius of convergence? Any idea? So similarly, you can do x raised to power factorial n, 2 raised to power n. That's another gap series, right? So these are some interesting things. So I hope now you are, you can do all easily this radius of convergence of business, right? Okay, so now we are ready with the Taylor business. So if you go, what we were doing here, Taylor series was something like this, right? So we wanted when a function can be represented by a series like this, right? And we know that the whole thing is that when mod of x minus a is less than r. So r is the radius of convergence, the way we defined, exactly in the same manner, right? So now, remember these coefficients we determine by that algebraic technique. Suppose these are unknown, you just solve the, differentiate and put x equal to a and so on and so forth. So now we have this value. So I take, so if a series is convergent, we know that if a series is convergent, if you take sum up to n terms, take the limit, that limit should exist, right? Sum up to n terms, partial sum, we call it partial sum, limit should exist, right? So here, that's why we define actually now, this is a sum of partial term, right? So from k is equal to 0 to n, so n plus 1 terms are there, right? Any finite number of terms you take, and take the limit, it should exist, right? So this expression we have called Taylor polynomial, Tnx of degree n. This is another degree Taylor polynomial. And if you remember, for this f of x is equal to e raised power x, and for a is equal to 0, t1x is 1 plus x, t2x is 1 plus x square by factorial 2 and so on, right? Now what happens? Since this is a sum up to n plus 1 terms, if you take the limit, it should give you f of x. Then we say the series is convergent, right? The value is f of x, right? Here, if I subtract, so what happens? F of x minus Tn of x will give you some portion of the series, right? And we call it as remainder. Rn of x, remainder. So remainder after n terms or n plus 1 terms, whatever terms are there. Now, actually, series will be convergent if Tnx goes towards f of x as limit n tends to infinity. In other words, when Rnx is 0. So remainder after a certain number of terms should be 0, should goes towards 0 as n approaches towards infinity. That's what is the key trick, right? So now, there are different form of reminders. People are very clever actually. These math people, So I am not going to tell you all reminder forms, but Rnx has different form here. Number one is Cauchy. Integral form. So I think I am leaving it as an exercise for you to check what are these forms at least, Third, and maybe you can also find your own form if you want, right? Try something and you determine anyway. So in any case, I want to show that when limit n tends towards infinity, Rn of x is 0. This remainder should go towards 0, right? Now I'm going to define what is known as Taylor's inequality. Actually, I'll estimate the value of Tn of x, Taylor polynomial, and then when you take the limit, you can show. So let me show you, and I'll give some proof in a very specific case, which is simple. Tough thing, I leave it for you, right? Whatever easy we should do in the class. Taylor's inequality. If mod of f of n plus 1, this is derivative with respect n plus 1 times differentiation, is less than or equal to capital M for mod of x minus a less than or equal to d, then reminder Rn of x of Taylor series satisfies this inequality that mod of Rn of x cannot exceed capital M times factorial n plus 1 mod of x minus a raised to power n plus 1. And this is true for mod of x minus a less than or equal for mod of x minus a less than or equal to d. This is kind of estimate. So if I have to show that the remainder goes towards 0, I'm just finding an estimate of it, right? And see the whole absolute value is less than or equal to this quantity. Now, if I take limit n towards n approaches towards infinity, if we can show that this quantity goes towards 0, we are done, right? Then remainder will go towards 0, right? So later on, we'll use this fact, okay? So remainder goes towards 0 if we can find this estimate. If there is some trouble, then there will be a trouble, right? We will not be able to do that, right? So basically, first of all, I will establish this fact that the remainder absolute value cannot exceed this quantity. Okay. M, what is M? Which is bound of derivative, all higher order derivatives, right? And for in the case when mod of x minus a is less than or equal to d, some fixed number. And so this is true for every n, right? So I am going to prove it for n is equal to 1. सबसे आसान केस है. N is equal to 2 के लिए you can take a cup of tea and then try to establish. It involves some tricks of integrations and so on. So और कुछ है नहीं. I think your JEE mathematics is enough for doing those integrations, right? So let me show you n is equal to 1 case. Okay. So I am going to prove for n is equal to 1. Proof. This empty square means proof starts, right? N is equal to 1. So for n is equal to 1, what will happen? So when n is equal to 1, this implies that mod of f double dash of x less than or equal to m by the given condition, right? From this condition, when n is equal to 1, 2 times differentiation of f of x is less than or equal to capital M. This implies that minus m less than or equal to f double dash of x less than or equal to capital M, right? Now, for a moment, I am assuming x is bigger than a. So we know that mod of x minus a is less than d, right? That means minus d is less than x minus a is less than d, right? This means a minus d is less than x is less than a plus d. X lies between these values, right? Now, for a moment, I am assuming that x is greater than a. In this interval, x is greater than a. Then what will happen? This implies that for a less than or equal to x less than or equal to a plus d, I am only taking these values of x. Similar can be done when x is less than or equal to a. I am leaving that thing. Okay. So when x is greater or equal to d, then I can integrate. So basically, from this expression, what I will have a to x integration f double dash of t dt less than or equal to a to x m dt. Can I do that? This is f of f double dash of t dt integration. I'm only taking one side of the inequality and just integrating from a to x, right? X को हमने t कर दिया है because you know x I'm taking in at the top, right? Okay. Now that means f dash of x minus f dash of a less than or equal to capital M times x minus a. Agree? ये तो simple because this is double derivative integrate करने पे f of t आएगा, right? And the plug in the values of the limit, right? समझ में आ रहा है? ये कोई मुश्किल काम नहीं है, ये तो हाई स्कूल मैथमेटिक्स है एक्चुअली, right? So now that means f dash of x this implies that f dash of x less than or equal to f dash of a plus m times x minus a, right? Now I am going to integrate again between from a to x on both sides. So this will be a to x f dash of t dt less than or equal to a to x f dash of a plus m times t minus a dt, right? Again I am integrating both sides between a to x. ये जो line आ जाती है बीच में, I am, it's beyond my control. Anyway, I do still could not have much practice here, but anyway. So we integrate a to x f of f dash of t, right? Again open. So this will be what? F of x minus f of a on the left hand side, right? And we can simplify what comes on the right hand side. Okay. So this implies that after simplification, we get f of x minus f of a less than or equal to f dash of a times x minus a plus m times x minus a whole square divided by 2. You can see that this is what you are going to get from here, right? When you integrate. Okay? This is what you are going to get. This implies that f of x minus f of a, this implies that f of x minus f of a minus f dash of a times x minus a less than or equal to m times x minus a whole square divided by 2. Now what is R1x? F of x minus T1x, right? So this is nothing but f of x minus f of a minus f of x minus f of a minus f dash of a times x minus a. So this implies that we can say that R1 of x is less than or equal to m times x minus a whole square divided by 2. Got it? This is minus, right? Because remainder is f of x minus t1 of x. T1 x of x value we know, I can compute here. So essentially R1x is nothing but this quantity that is coming on the left. So R1x is less than or equal to m times x minus whole square by 2, which is factorial to anyway. So basically, we are getting the inequality. If you see the inequality, for n is equal to 1, this is mod of x minus a whole square factorial 2, right? The whole thing is established, right? So now you may say that what about the other values of x? Similarly, it can be done. So that's the way people write, right? Similar other case you can do. Of course, they don't know that it requires bunch of hours to do those things again, right? But anyway. So basically, in fact, this is one side. So what we have established is one side, the upper bound. What about the lower bound? Because we have to show that the absolute value is less than or equal to this, right? So that means, in fact, you can show that if you use this inequality, that f double dash of x is, at least minus m, and similar techniques will show you that r1 of x is lower bounded by minus m by 2 x minus a whole square. And this implies that absolute value of r1 of x cannot exceed m times m by 2 mod of x minus a whole square, right? So this is how you compute. So again, in this result, I have assumed x is greater than a. Okay. One can show that when x is less than a, and I'm leaving that, right? But you can also show that. Okay. Just तुमको थोड़ा सा idea देना है ना how it works, right? I mean, there is no need to memorize or whatever, right? So I never ask proofs, right? So all your mental skills, right? So this is fine. So that means we know the Taylor's inequality. So maybe only for one case, for n is equal to 2, if you want, you can try. I'm not forcing you, but see if you can prove it for n is equal to 2. So that means the expression will be more, lengthy. Some calculations will be lengthy, right? The most important thing is it requires patience, right? Sitting. So many times what happens, there was a mathematician, John H. Conway. So there was an open problem in mathematics. And, so one day he said, okay, fine. He went to his office and continuously working. He was there in the office. He closed himself in the office for about 48 hours or 70 hours, something like that. And he came up with the solution. So that kind of patience is required. Concentration, focus. You can have a cup of tea and coffee, whatever, but work on the problem with that kind of dedication, you will be able to solve it, right? And it requires uplifting of your brain. Okay. So many times actually problems are difficult to solve. I remember in my PhD, I took an open problem and it was a difficult problem. I could not do it. And after 8 months, one day when I was walking in the library, suddenly a solution came into my mind and it was a very simple solution. So you see, it goes. So if you are working on a problem, if you give enough time to a problem, that is start working on your back brain, right? And then someday solution will come. So these kind of things happens quite often when you spend enough time, right? So karat abhyas jalamati ho sujan, right? So if you do enough practice, give you enough exposure, you will be able to do it anyway. So this is the Taylor's polynomial. Similarly for x less than a. So I'm, not proving it. Now I'll give you one example here. Again, our favorite example. X raised for n divided by factorial n. Right. I have to show that this is true for every x in R. Okay. So here f of x is e raised for x. This implies that n plus 1th derivative you can compute of x will be e raised for x for every n. Right. If d is a positive number, suppose, and mod of x less than or equal to d, then n plus 1th derivative of x absolute value, which is e raised for x, will be less than or equal to e raised for d for that fixed number, right? Then using Taylor's inequality for a is equal to 0, Taylor's inequality, I will call it is t less than or equal to Taylor's inequality, shorthand form, right? A is equal to 0, we get mod of or n of x cannot exceed e raised for d divided by factorial n plus 1 times mod of x raised for n plus 1. This is true for mod of x less than or equal to d. Okay. Note that this bound m here, which is e raised for d, works for every n, right? So there is no issue, right? Its value is same, right? Differentiation will give you the same thing, right? So here is using Taylor's inequality, we arrived at this. Now, if I take limit n tends towards infinity, what will happen on the left hand side? We want the limit. What happens on this side? What is the limit of this as n tends towards infinity? Huh? 0, right? ये तो high school mathematics का limit निकालना, right? So why is that? Because any polynomial, this is kind of polynomial, right? And this is factorial. This goes towards infinity faster than this. And so the overall thing will be 0, right? So from sandwich theorem or whatever, squeeze theorem, so Rn of x is 0. Because limit n tends towards infinity, x raised to n divided by factorial n is 0. And hence the result, right? बस इससे ज़्यादा नहीं करना है, that is enough. ज़्यादा काम है नहीं actually. तुम्हारे कितने? I think there are about 11 lectures, right? You need to watch now, revise. So from now and then probably in the next lecture, I'm going to revise. Okay, so you can take 1 minute break, clear up everything. So what are the topics? Whatever we have done till now is going to be in the exam, right? What are the topics? Can you repeat? Countable business, limit, continuity, differentiability of single variable, and the properties like Rolle's theorem and Taylor series. है ही क्या course में? Right? कुछ ज़्यादा है नहीं ना? भाई लिमिट तुमने पहले से पढ़ा हुआ है, कंटिन्यूटी पहले से पढ़ा हुआ है, डिफरेंशिएबिलिटी पहले से पढ़ा हुआ है, राइट? टेलर सीरीज भी पहले से पढ़ा हुआ है, देखा है तो बहुत हलवा है. So you may ask me as many questions as you want, so I am available today and in the next class. Normally I used to keep some office hours before that, but anyway WhatsApp is available 24/7. If there is something, see, as I observed, there is a problem in the radius of convergence, so I covered that stuff, right? If something I observed it's not clear to you, I will give it to you, those things, right? So discuss there. Any question? कौन सा सबसे मुश्किल टॉपिक लगा? हाँ? Countable. By the way, in countable also, I should tell you one thing. I have given you the definition that if a set is finite, it is always countable. If set is infinite, I gave you a definition that they should be 1-to-1 and 1-to map from natural numbers to that set, right? You can relax. This is a bit stronger condition. You can also relax. Even if the function is 1-to-1, we are done. I mean, that's something you should know. This definition is used mostly with computer science people. This, the 1-to-1 and 1-to, because they're, but it's fine, So if you are able to only establish 1-to-1 function, then also it is countable. A set. Okay. So basically, this turns out 1-to-1 and on-to function means you give me one thing, I give you another thing, you give me another thing, So if I say that set of even integers are countable, right? So you give me 0, I'll give you something. If you give me some other, right? If you give me 2, I will give you another integer, natural number. If I give you 4, you give another natural number, right? So there is a correspondence. That's why it looks more natural. That's why I give you another definition of 1-to-1 and on-to function, which is okay, right? If you are able to show this, the function is countable 100%. Huh? Huh? Natural number तो rational. वो तुमने बताया ना वो. अब तुमको खाली उसमें फंक्शन निकालना है, वो अभी तक नहीं निकला होगा शायद. अरे इतना आसान थोड़ी है जो मैं पूछूंगा तो भी. So it is, वो फंक्शन निकालना इज अ ट्रिकी थिंग. कौन निकाल के आता है? देयर आर पीपल, स्मार्ट पीपल. साइन ऑफ एक्स क्यूब किसी ने सॉल्व किया था. हु सॉल्व्ड इट? अच्छा तुमने. तो फिर तुम इसका भी निकालो ना फंक्शन. इट्स बिट नॉन ट्रिवियल. एंड पर ये निकालने में ही तो मजा है ना, अदरवाइज मजा खत्म हो जाएगा तुम्हारे लिए ना. इफ यू डिस्कवर समथिंग ऑन योर ओन, यू एंजॉय मोस्ट, राइट? अरे मैंने निकाला, राइट? कॉन्फिडेंस आया था ना. तो फिर वही तो है ना, वो फंक्शन निकालना है, विच इज, even if you are able to find 1-to-1 function, that is okay. Okay. बाकी rational numbers में क्या है? You just arrange in that array and just count 1, 2, 3, 4, right? Initially you assume it's a positive ones, right? If you include zero, start from 0, 0, put it at the beginning, and negatives you can slide in between. So the same mechanics works, right? And I gave you a hint. The function is related to the height of the number. You can define height of the number, and then try to correlate with it, right? So normally, so I gave you one example of this binary things, right? Because that is useful in computer science. Actually, you will see that using that concept, there are more number of languages than the number of Turing machines. So that's why there is a Turing barrier. There are problems for which Turing machine cannot solve, and Turing machine is the ultimate computer that you use, right? So it uses the same counter diagonalization argument, right? Otherwise, you can, I mean, there are questions like open interval 0, 1 is countable or uncountable, uncountable. Write down the decimal expansions, right? Again, in the same form of array, right? And produce a number which is between 0 and 1, but which is not in the list by taking in the first diagonal complement. Second entry of the decimal complement in the sense here, since it is, if it is 5, you just subtract 9 minus 5, right? Fix a number 9, right? And then if it is 3, 9 minus 3 is 6, right? So like that, you produce a number. That number will never be in the list, right? So शास्त्र अनंत है विद्या का पारावार नहीं, ऐसे में मनुष्य सदैव मूल तत्व पर विचार करना चाहिए, राइट? और मूल तत्व क्या है? लिमिट कॉन्टिन्यूटी डिफरेंशिएबिलिटी की एप्सिलॉन डेल्टा, राइट? If you focus on epsilon delta, you can do anything, right? Are you getting that power? Epsilon delta can do anything, no? Actually, many times you will observe that you are doing some maybe, for example, आजकल वो चर्चा में है ना, चैट जीपीटी. So large language model based, right? So see in that LLM, so you may encounter while doing certain things, maybe a series. Actually, in in this natural language processing, again you use a lot of calculus there also. So basically, it's all very basic thing. Many times, if something is, suppose some unknown series is coming, how will you approach it? कोई फॉर्मूला थोड़ी है ना उसके लिए तुम्हारे, अरे इसका फॉर्मूला मिले. अब जैसे गैप सीरीज थी, आई गिव एन एग्जांपल ऑफ अ गैप सीरीज, राइट? हाउ विल यू अप्रोच, राइट? यू हैव टू समहाउ शो. मैंने तो आंसर बता दिया, हर समय तुम्हें आंसर बताने वाला नहीं है व्हेन यू आर ड्राइविंग, राइट? सो आई वांट यू टू बी इंडिपेंडेंट ड्राइवर, राइट? सो फॉर दैट you have to approach, use your brain. That skill is important. How do you approach a problem? Many times, suppose you go for an interview, they don't expect that you are able to answer all the questions, but your approach, how do you approach a problem? That is very, very important, right? So how do you approach, right? What is the thinking? वो thinking process develop करना है, बाकी और कुछ नहीं है, right? पूरे I think calculus का सार यही है ना, till the all end, right? So by the way, your exam paper is ready. There are 4 questions. One question is bit non-trivial, I mean, beautiful basically, and there are there are 3 which are bit easy, right? Okay, 4 क्वेश्चन है, क्वेश्चन पेपर के ऊपर ही लिखना है. So you have to write on the question papers. So basically what I am expecting you, आपको जो कैलकुलेशन करना है वो रफ में करके क्रिस्प आंसर. आई वांट इवन इफ फॉर 4 लाइंस 5 लाइंस, आर्गुमेंट क्लियर कट, कोई फालतू का नहीं. एंड हाउ टू राइट सैंपल राइटिंग आल्सो आई हैव गिवन यू, राइट? यू सी हाउ टू राइट इट प्रिसाइज. वो एक पेज काफी है पूरा क्वेश्चन करने के लिए, राइट? डू ऑल द कैलकुलेशंस जो भी करना है. और नॉर्मली देयर आर 4 क्वेश्चंस, ईच क्वेश्चंस यू कैन डू इन 15 मिनट्स, राइट? हर क्वेश्चन पे 15 मिनट्स एक्स्ट्रा है फॉर थिंकिंग. So you have half an hour for one question. So it's very easy. कोई एक लड़का आया था, मैं पता नहीं यहाँ पे है कि नहीं, वो बोला था मेरे को सोल्यूशन सब दे दो मैं याद कर लूंगा, राइट? सो वो सब नहीं हुआ, सोल्यूशन तो नहीं हो गया, राइट? ओके, तो देखा जाए पेपर बहुत आसान है इस बार एक्चुअली. तुमने सैंपल्स तो कुछ देखे होंगे, राइट? सम ऑफ देम आर बिट ट्रिकी, बट ठीक है, बिकॉज सिंस यू आर न्यू टू द सिस्टम, पहला पेपर काफी आसान है. सेकंड विल भी थोड़ा सा और ब्यूटीफुल होगा, बट ठीक है. any other question? So in the next class I'm going to summarize few key points, just reiterate whatever it is then, so that you are ready. Okay, and still if you want to meet me, if you are something you really want, you can always message me, although I'm a bit busy, but anytime you can message me. If I am there, I will say that okay, come and ask, right? Okay, so I'm available on WhatsApp. Anyway, I watch. Normally till 4 o'clock, you must be seeing I've given you something in the night. So some of these notes are from IIT Kanpur of Professor Shamug Raj. So he's a good friend of mine. So he's uh, prepared those notes at IIT Kanpur because I, taught initially at IIT Kanpur. So these are the things which you should know. So you can read some of those notes also, additional reading material if you want. Thank you. By the way,